Let me share my screen. Let me share yesterday's class again. Okay, I'll just give you a review of yesterday's class. Okay. So my screen is visible to you. My screen is visible. I have shared one screen. So is this visible? My screen is visible. Yes or no?
No, ma'am.
No. Okay. Just wait. Now? 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 I
Yes,
think
ma'am. It's
now
visible.
it is visible. Yes. So, what is hydraulic jump? When depth of flow, when flow changes from supercritical supercritical to subcritical, then hydraulic jump occurs. Okay, what is subcritical? When fraud numbers FR fraud number is greater than 1. In that case, the flow is subcritical. Already you know these things. Okay, what is subcritical, what is supercritical, isn't it? So in case of supercritical, fraud number is greater than 1, and in case of subcritical, fraud number is less than 1. And when hydraulic jump occurs, a loss of energy due to eddy formation and turbulence flow occurs. So when there is hydraulic jump, a loss of energy occurs. Okay, why? Because due to the formation of eddies, when hydraulic jump occurs, that is the turbulence occurs, and some eddy means 3D like flow. Okay, so some eddy formation and turbulence flow occurs, and due to this, a loss of energy occurs when there is hydraulic jump. So can you see in this figure? See, the fluid is flowing from supercritical to subcritical, and in between them there exists a hydraulic jump. So this is the location of hydraulic jump when flow changes from supercritical to subcritical. Okay. Again, uses of hydraulic jump. There are various uses of hydraulic jump. Number one, hydraulic jump can be used to dissipate or destroy the energy of water where it is not needed. Otherwise, it may damage to hydraulic structure. That means hydraulic jump can be used to destroy the energy of water when the energy is not required in case of any hydraulic structures. Any hydraulic structures like dam, wheel. Okay, canals. These are hydraulic structures. Dam is a bigger hydraulic structure. Okay. And next is, it may be used for mixing certain chemicals in case of water treatment plant. So I think already you know what is water treatment plant: screening, sedimentation, plain sedimentation, chlorination, filtration, all these included in water treatment plant. And in case of water purification process, some chemicals is required to purify the treatment water. Okay, and to mix that chemicals, hydraulic jump can be used. And how hydraulic jump can be used? Suppose in the treatment plant, in the entrance of the water, they created one hydraulic jump by providing some barriers to the flow. Okay, and chemicals is added in the portion of hydraulic jump, and that's why that chemical is mixed thoroughly with the help of the turbulence of hydraulic jump. Okay, so in this way hydraulic jump is used in case of water treatment plant. Next, number 3, it may be used as a discharge measuring device. So there are various discharge measuring devices: orifice, venturimeter. So along with that, hydraulic jump is also used as a discharge measuring devices. Next, just wait a minute, okay? So in this figure, you can see a sluice gate, a barrier is provided in a channel of water, and the flow of water is subcritical. If you provide a barrier, suppose a sluice gate, then it undergoes supercritical, and from supercritical to again subcritical, they form hydraulic jump. Okay, this is your hydraulic jump, and the flow again behaves as a subcritical flow. Okay, so this is the flow under a sluice gate from subcritical to critical to supercritical, and then jumps back to subcritical flow. Next, let's move to the next slide. Classification of hydraulic jump. So on the basis of Froude's number, what is Froude's number? It is the ratio of inertia force to gravity force. So on the basis of Froude's number, hydraulic jump can be classified as angular jump, number 2 weak jump, oscillating jump, steady jump, and last one is strong jump. What is weak angular jump? When Froude number is in the value of Froude number is in between 1 to 1.7, the jump is angular jump. When it is 1.7 to 2.5, it is weak jump. When Froude number is in between 2.5 to 4.5, it is oscillating jump. When it is 4.5 to 9, the jump is steady jump. And if Froude number is equal to 9 or greater than 9, equal to 9 or greater than 9, the hydraulic jump formed is called strong jump. You can see in the figure 1, it is showing an angular jump. In figure B, weak jump. Third figure, it is showing oscillating jump. Number 4 figure, it is showing shows steady jump. And last one is strong jump. Generally, steady jump can be used in, that means water treatment plant or construction of hydraulic jump. Can you hear me? Are you able to hear me?
Yes, ma'am.
Okay. So generally steady jump is used for design purpose for construction of hydraulic structures. Next, classification of hydraulic jump. Fraud number is less than 1, jump is impossible. If fraud number is less than 1, there is no chance of hydraulic jump and it violates second law of thermodynamics. When fraud number is between 1 to 1.5, standing wave, or it is called undulator jump, about 4y2 long, low dissipation, less than 5%, energy dissipated at about 5%. Third point, fraud number is in between 1.7 to 2.5. Smooth surface, rise with small rollers, known as weak jump. Energy dissipation is about 5 to 15%. Number 4 point, if fraud number is in between 2.5 to 4.5, the jump is oscillating, unstable, irregular pulsation, large wave which can travel downstream for miles, damaging earth banks and other structures. Not recommended for design condition. Dissipation is about 15 to 45%. So oscillating jump is not recommended for construction of hydraulic structures because it is unstable, irregular pulsation creates, and it may damage to the earth banks. It may damage to the banks of the hydraulic structure. That's why. Sorry. Number 5. If fraud number is between 4.5 to 9, the hydraulic jump is stable, well balanced, steady, best performance and action, insensitive to downstream condition, best design range. Energy dissipation is about 45 to 70%. Next, when fraud number is equal to 9 or greater than 9, the hydraulic jump is rough, somewhat intermittent strong jump, but good performance. Energy dissipation is about 70 to 80%. So these are the characteristics of various hydraulic jumps. Next, application of hydraulic jump. Usually, hydraulic jump reverses the flow of water. This phenomenon can be used to mix chemicals for water purification. Number 2, hydraulic jump usually maintains the high water level on the downstream stream side. This high water level can be used for irrigation purpose. Okay, so hydraulic jump usually maintains the high water level on the downstream side, and that is why it can be used as the irrigation purpose. What is irrigation? Flooding in crop field. Okay, the watering in a field crop for growing crop, that is called irrigation. Next, hydraulic jump can be used to remove the air from water supply and sewage lines to prevent their air locking. Last one. Hydraulic jumps prevents the scouring action. Scouring means erosion, removal of soil particles. Removal of soil particles from an area due to the action of some hydraulic forces. Hydraulic forces means due to the action of water. That is called scouring. Okay. So scouring is nothing but the erosion of river bank or soil due to the action of water forces. That is called scouring. So it prevents the scouring action on the downstream side of the dam structure. So generally scouring action occurs in the downstream area. Suppose a river, it is flowing from an origin and to the end. Where it is originate, it is called upstream portion, and the downstream portion means when to where it is flowing, that is called downstream area. Okay. So generally what scouring action occurs in the downstream area of any hydraulic structure. Next, location of hydraulic jump, where it is located. The most typical cases of the location of hydraulic jumps are: number 1, below control structures like weir, sluice are used in the channel. Number 2, when any obstruction is found in the channel. Suppose in a channel water is flowing. If there is an obstruction, then it may create hydraulic jump. Number 3, when a sharp change in the channel slope takes place. Suppose water is flowing from a gentle slope to a steep slope. Then hydraulic jumps may occur. Next, number 4, at the toe of spillway dam. Dam is a trapezoidal structures. Okay. So this is the backfill. This is the upstream of a bank. Suppose this is a dam. It is a trapezoidal structure. It may be constructed, it may be art dam, or it may be a concrete structure. Generally dams are a masonry structure. Okay. So at the top of the dam, this is the toe. So hydraulic jump generally occurs at the toe portion of a dam. Next, effect of hydraulic jump. Actually, hydraulic jump usually acts as the energy dissipator. It clears the surplus energy of water. Next, due to the hydraulic jump, many noticeable disturbances are created in the flowing water like eddies, reverse flow. Next, usually when a hydraulic jump takes place, the considerable amount of air is trapped in the water. That air can be helpful in removing the waste in the stream that are causing pollution. Next, last one, hydraulic jump also makes to work of different hydraulic structures effective like wire, notches, flumes, etc. Next, height of hydraulic jump. So generally height of hydraulic jump is denoted by Hj. Okay, H suffix J, and Hydraulic jump is the difference of depths before and after the jump is known as height of the jump. So height of the jump generally denoted by y2 minus y1. Where y2 is equal to y1 divided by 2, y1 divided by 2 root over 1 plus 8 Froude number square minus 1. This is the formula of depth of water in case of hydraulic jump. Okay. So y2 minus 1, y2 equal to y1 divided by 2 whole into root over 1 plus 8 Froude numbers fr square minus 1. Okay. If you know the value of y1, then you can y1 and Froude number, then you can calculate y2. So after calculating y2 and y1, you can calculate the height of jump. Okay. Next is length of jump. Length of jump. The distance between the front face of the jump to a point on the downstream where the rollers, eddies terminate and the flow becomes uniform is known as the length of the jump. The length of the jump varies from 5 to 7 times its height. An average value is usually taken as length of the height. Length of the jump is equal to 6 times of height of jump. Okay. So length of the hydraulic jump is equal to 6 times the height of the jumps. Energy loss diagram. So this is the loss of energy when there is a hydraulic jump occurs. Suppose this is the depth of water y1, this is the depth of water y2, q is the discharge, v1 is the velocity in the cross section 1, v2 is the velocity in the cross section y2 after the jump. This is the hydraulic jump. This is the E1 is the energy before the jump, E2 is the energy after the jump, and change in energy is equal to delta E. Okay, so delta E, that means the loss of energy will be E1 minus E2. So delta E is equal to E1 E1 minus E2. Okay, and this is the supercritical condition, this is the subcritical condition. So hydraulic jump with H and head loss. This is the energy loss diagram of hydraulic jump. Have you understood? Yes. Head loss in a hydraulic jump. Due to the turbulent flow in hydraulic jump, a dissipation of energy occurs, and that energy is equal to E1 minus E2, and HL is the head loss. So head loss equal to E1 minus E2. What is E1? Energy after the energy before the hydraulic jump, and E2 is the energy loss of energy, energy after the hydraulic jump, and E is the specific energy. You already know what is specific energy. And for rectangular channels, specific energy is equal to y plus q square divided by 2z y square. This formula already I have given to you, isn't it? So for rectangular channel, specific energy equation is equal to y depth of flow plus q square unit discharge divided by 2z y square. So in case of head loss, in case of hydraulic jump, the head loss will be equal to y1 plus q square divided by 2z y1 square minus y2 plus q square divided by 2z y2 cube. Let me confirm. So HL will be y1 minus y2 whole cube. It should, I think it should be cube. This is cube. Y1 cube. Okay. So loss of energy, after simplifying we will get y loss of energy is equal to y1 minus y2 whole to the power cube divided by 4 y1 y2. So this is the loss of head in case of hydraulic jump. Okay. So here the formulas are given. After that, one problem is given to you. So let me finish this slide. So hydraulic jump in case of rectangular channel, y2 value is equal to minus y1 plus root over this one, and y2 equal to this one. Ratio of conjugate depth. This is y1, this is y2. y2 is the depth before hydraulic jump. Y1 is the depth before hydraulic jump and y2 is the depth after formation of hydraulic jump. So the ratio is conjugate depth. So y1, this is the ratio, y2 minus y2 divided by y1 equal to half of minus 1 plus 8 q square divided by z y1 cube. Okay. One numerical problem is there. Find out the depth of water after the hydraulic jump in a rectangular channel of 4 meter with having a discharge of 16 meter cube per second. The depth of water in the channel before hydraulic jump is that one. So you have to find out the depth of flow. Can you solve yourself? Can you try yourself? Find out the depth of flow of water after the hydraulic jump in a rectangular channel of 4 meter width. Width of rectangular channel is given and having a discharge Q value is given. The depth of water in the channel before hydraulic jump Y1 value is given. Okay, you have to find Y2 value. Okay, you can use this formula, Y2 divided by Y1 equal to half of minus 1 plus root over 8 q square 8 y1 cube. Q value is given, y1 value is given. Find out y2. Okay. So thank you. So I will share my notes later. I will share these notes to you later. Okay. Okay, so how many students are there? 27. 4 participants are in the lobby. What? Are in the lobby? Why they? So total student is 31 today. So let me note down your roll numbers. So next class I will discuss the next topic. Okay, thank you.